Before we discuss the first law of motion, let us quickly recall our understanding of force. Force is a push or pull that changes the state of rest or motion. Force is a vector quantity, and the SI unit of force is Newton. Let us now use this knowledge to understand two cases. In the first case, we have a box lying upon a granite surface. Let us assume that there is no friction. We know that force causes motion, but what if this box is acted upon by two forces of 50 Newton each from opposite directions? Obviously, this box will not move. But let us reason out why. Since force A acts towards the right, it would be positive, and since force B acts towards the left, it would be negative. So the net force acting upon the box would be positive 50 Newton plus negative 50 Newton, and that is equal to 0. In other words, the forces acting upon the box are balanced, and therefore the box would continue its state of rest. Now, if force A increases to 70 Newton, the box would start moving since there is now an unbalanced force acting upon the box. The conclusion we can draw from this observation is that an object continues its state of rest till an external unbalanced force is applied upon it. Now, let us understand the second case. In this case, the box is moving with a uniform velocity of 4 meters per second upon the granite surface. Once again, let us assume that there is no friction. As in the previous case, the box is once again acted upon by the forces A and B simultaneously such that they are balanced. Since the net force acting upon the moving box is 0, its velocity would neither increase nor decrease. In fact, the box would continue to move at a constant velocity of 4 meters per second. Now, if force A increases to 70 Newton, the velocity of the box would increase, since there is now an unbalanced force acting upon the box. The conclusion we can draw from this observation is that an object continues its state of uniform velocity till an external unbalanced force is applied upon it. We may now combine the conclusion of both the cases into one single statement, and that is, an object continues its state of rest or uniform velocity till an external unbalanced force is applied upon it. This statement is called Newton's first law of motion. However, it is interesting to note that the foundations of this law were actually laid by Galileo, who died in 1642, the same year that Newton was born. Galileo stated that an object could have two natural states, a state of rest or a state of uniform motion. And to change these states, a force would be required. This tendency of an object to remain in its natural state is called inertia, and hence the first law of motion is also called the law of inertia. The tendency of an object to remain in its natural state of rest is called inertia of rest. Similarly, the tendency of an object to remain in its natural state of uniform motion is called inertia of motion. So let us look at an example of inertia of rest. Consider this bottle that is kept upon a small toy cart. What happens when the cart is suddenly pulled forward? The bottle falls backwards. This is caused due to the bottle's inertia of rest. When the cart is at rest, the bottle is at rest. However, when the cart begins to move, the base of the bottle that is in contact with the cart also begins to move. But the upper part of the bottle continues its state of rest and therefore tends to remain where it is. This causes the bottle to fall backwards. Now let us look at an example of inertia of motion. In this example, let us consider that the bottle is mounted upon the cart and the cart is in motion. What happens when the cart is suddenly stopped? The bottle falls forward. This is caused due to the bottle's inertia of motion. When the cart is in motion, the bottle is in motion. However, when the cart is suddenly stopped, the base of the bottle that is in contact with the cart also comes to a sudden halt. But the upper part of the bottle continues its state of motion and therefore the bottle falls forward. In both these examples, we saw that the bottle falling backward or forward was due to its resistance to the external force that caused it to move or stop. Hence, we can conclude that inertia is a body's tendency to resist an external force. So, if you have two boxes with different masses, you will observe that the box with a greater mass will require a greater force to move or stop. Hence, it has a greater tendency to resist an external force. This means that inertia is a measure of a body's mass. Greater the inertia, greater is the mass. And now, the summary of this video. Two forces are said to be balanced if they are equal in magnitude, opposite in direction, and act simultaneously along the same line. The first law of motion states that a body will continue its state of rest or uniform motion in the absence of a net force. The tendency of an object to continue its state of rest or motion is called inertia. There are two types of inertia: inertia of rest and inertia of motion. Inertia is a measure of the body's mass. Greater the inertia, greater is its mass. So that's all in this video. In the next video, we will discuss Newton's second law of motion.